Okay, let's just look at this picture, folks. I think this will be sufficient. So I was just trying to make sure that we're in the right area. Let's just grab this, right? And I will highlight what we are looking at so that you get a view of, why we are looking at the probability and what is the threshold optimization all about, right? Okay, so over here, let me just highlight very quickly what we are looking at, which rows you have to focus on. So we're looking at 1, 2, 3, 4, 5, 6, 7. And over here, 1, 2, 3, 4, 5, 6, 7. So if you look at the first observation, what is the predicted class, people? Anyone? What is the class that was predicted by the model?
Zero.
Zero.
0. And over here, the probabilities are 0.67 and 0.32 something, right? What does it mean?
So the probability of a zero is 67%.
That's correct. So the probability of this particular observation belonging to class 0, which is non-survived, is 67%, and probability of this passenger to be surviving is 32%. So that's what the model predicts, right? For each passenger, it will predict the probability it belonging to one class versus another class, because the default threshold that the model uses is zero point 0.5. So if the probability of one event to be happening is more than 0.5, it will be put in that class, right? So you can see the probability of to be 0 is 0.67. Hence, the predicted class is 0. Here, what is the probability of being class 0? 89%. Again, the predicted class is 0. Third observation, 89. Again, that. Fourth observation, again 89, right? Fifth observation is 67. Again, that. So you can come over to the observation number 7. What is the probability that this passenger will be surviving? 51%. 51%. This passenger will be surviving. It is more than 50%. So hence the predicted class is 1. So I hope this you are able to correlate how the probabilities prediction translates into the actual classes that we're actually having for that, right? And then you can do the same thing for other ones, right? So then what we're going to do is we will talk about the threshold optimization. Let's say we are not very comfortable with this, right? The first thing you should do in terms of optimizing the model performance, and I'm sorry, I shouldn't have run this because it's running a random forest, which will take at least 7-8 minutes, right? And post that only I will be able to execute. But what you can do is when you are running your tree, in the instance of the tree that you've created, go ahead and make one change over here. Over here, can anyone tell me what will be the command that you have to put to make the class balanced? Can you quickly look up the syntax of the decision tree classifier and give me what will be the command that you have to put to do class balancing within the instance? Anyone? There is a command. So if you go to sklearn decision tree classifier, right? Just go and take a look.
Yeah, wait underscore class.
Right. So over here, you will see class weight is none. So right now it's saying I'm not gonna give any special weightage to any classes. So if 0 is much more than 1, it's gonna learn the behavior of 0 more, because it's just more data point to get trained on, right? So if you look at the precision and recall, you will see that looks a lot better for 0 compared to the 1. Where is it? Yeah, over here, right? So look at the precision and recall for 0. Significantly better, right? 0.78 versus 0.73 precision, 0.89 versus 0.55 recall. So for 0, it's better. Why? Because we have more observations in the 0. So more data to learn from, better the model for that, right? So now we're going to say class weight is balanced and rerun the model and see whether that picture changes, right? So you will come down over here and you will just say class weight is equal to balanced and rerun the algorithm and see whether this looks better. Quickly, let's see whether your confusion matrix has become better now after this. Sorry, Rish, question. Same, but just over here, no, you can change it there only. Or you can say optimizing model performance, just create a heading and say class weight balanced as one setting. We're gonna do many optimization. We're just gonna start with one of them. Unfortunately, I cannot run it because it's just running something. So you can see it's executing in the below line. Hopefully it will take maybe a couple of more minutes. Hmm? Running? Yeah. Class weight balanced. That's all you're doing as of now. Okay. What became one? Mm-hmm. Hmm. Okay. I'll just do that. I think mine has also run. Yeah, random forest has run as well. We'll talk about that later on. Yep, that's fine. So now we're talking about the optimization, right? Model performance, how to make it better. So one of the first thing that you got to try is this one that we just spoke about. Right. So I will go over here. And another thing you will notice is that if you're in the Google Colab environment, right? So it will give you the IntelliSense feature, right? Which is actually, if you're not sure, because I don't remember them, right? So you can actually figure out what are the things that you should be looking at. So for example, you'll say that it's automatically giving me that Jupyter notebook, it's not that handy. You have to do some, press some key, then it comes in. But over here, it is automatically coming in, right? So I'm just going to put class weight, right? Class weight, see, you can now see that it's automatically giving me that, right? So I'll just have to double click on it and then balanced, right? Let's rerun.
I do not have any improvement.
You don't have any improvement. That's okay. I mean, it's not guaranteed step, but at least you should try that as a first step, right? It may work, may not work. So remember this, I'm just going to take a snippet before I run it. So this is without the class weight balance, may work or may not work, right? So now I'm going to rerun it and let's grab it. I think there is no improvement, right? I mean, as people are saying. So if there was anything with respect to the imbalanced data, this would definitely have helped. But in this case, it's saying, it's not going to make a huge difference to me. So there are some changes or no changes at all. Did I run it or no? I don't know because it looks identical. How about you folks? Any difference or same? Same.
For me, no difference.
Huh? Okay, the values have changed, but not the like. So it probably didn't create much difference. Okay. So some improvement seen with like some of the folks, but most of us, we are not getting any improvements, right? So that's okay. Now we're going to talk about the threshold optimization as one way of improving. Who would like to remind us what is a recall, what is a precision again? So for example, And because that's where this is coming in really. So what will be the interpretation of 0.55 in plain English? Amit, you want to take a stab? No? Okay, that's fine. You want to volunteer somebody else in the class who should answer on your behalf? Or online also, you can say.
Okay, I will answer it.
Okay, go ahead. Krishna?
Yeah.
Yeah, go ahead.
Yes, sir. So precision is correct classifications among the correct predictions made.
Mm-hmm.
And
Remember the cat
recall,
and dog we spoke last time, same way. If you can
yeah.
explain what does 0.55 mean?
Okay. Where is that? So
Because unless you understand this,
yeah,
yeah, go ahead.
0.55 says that uh, out of the all, it's 0.55% of the correct predictions is made. I
Nope,
mean,
nope. Ganesh, any idea of what 0.55 means?
Out of all the 1.55, one predicted correctly.
From all the ones, 0.55 were predicted correctly.
One
Ganesh, you were
as
saying
one.
or yes. Okay, Chirag? Not quite. It means that my model is able to correctly identify 55% of the survivals correctly, right? 0.55 means like if 100
right,
passengers would have survived in the water, my model is only able to detect 55% of them, right? And
right,
if I don't have a model, I would have 50-50% odd, right? So if I grab a person, 50% chances of survival, 50% chances of not survival. So my model is not really doing that much better compared to like, not having any model, because that anyways would have been 50-50% chance, right? I mean, I can close my eyes and grab a person, half the probability that will survive, not survive, right? My model is only having a recall of 0.55. That means it is able to correctly identify only 55% of the survivors. 45% of the survivors are not detected correctly by my model, right? So that's what basically 55 means. And it's not a good number, right? So let's say business says that you have to build an algorithm which has a minimum of 70% recall. Then only I'm going to use your model. That way, at least you are able to detect 75% of the passengers who would have survived correctly. Then I will take your model and apply that, right? So right now your model is no go, right? So even though the accuracy number may look fantastic, all the other numbers may look decent, right? But it's not an implementable model. So how would we go and actually modify the model performance so that the recall becomes better? And recall particularly for the class one is what I'm looking at. I hope this is clear, right? So the model is not good enough from that point of view. So one of the things that you have to do is do the threshold optimization, which is what I'm going to talk about now. Then we'll come to the hyperparameter. Right. So this is the same table as what we have done earlier. So you can see, I think I've run it, right? Yeah. Should be good, right? No, I did that class balancing as well, right? So let me just run one more time so that I'm current on that. Oh, it's running everything. That's okay. Let it run. One more time, I'm running everything because I did some changes there. Sorry. Huh. it has become better for you. So there are certain cases where it has become better. Let me just do one more time, people. I think it got confused. So I'm restarting the kernel and rerunning it. And I'll come to the probability part in a minute, right? So now it should go through as per the plan. Yep, it's moving forward. Otherwise, it's getting confused. So now I'll highlight the probability part. So we've already done the class balance. And in most of the cases, that is not giving us anything better than what we had originally, right? So the class balance came in. Came in over here, right? So we already tried the class balance, did not work out for most of us. Now we're gonna go and look at the threshold optimization, right? Right. So I was talking about this section over here. So you can see the probability of 0, probability of 1. What is the predicted class? What is the actual class, right? So this is some data I actually just merged many different things. You can ignore that, right? But this is, you can see how the actual probabilities translate into the predicted class and how the actual class is. And the predicted and the actual will give you the confusion matrix, right? So for example, this is misclassified information. Why is it misclassified? Row number 33, who can tell me? What is the probability that it will be non-survival?
The non-survival probability is 56%, and the survival probability is 43. So based on that, it predicted 0 because zero's
Correct.
probability is more.
Correct. So this is a borderline observation. So it says there is a 56% probability that this passenger is not surviving, 43% surviving. So it said, I'm going to put this passenger as a 0, that not survival, but in reality, this passenger actually did survive. So that's a wrong classification. Let's pick one more example. I was looking for 10, but 10 is not here. Where is it? This one. So this one, right? So it says 71% probability of survival. Hence, the predicted class is 1. The actual class is 0. Again, this is a misclassification, right? And that's what basically results in your confusion matrix, right? Now let's go ahead and look at this. You can copy paste this and tell me what do you think we are doing over here, right? So I'm just gonna slowly build towards the threshold optimization. So I'm just grabbing this row. Who can tell me what this row is? What are we doing?
Zero probability, you are rounding to 3 decimal point.
Zero probability? No, this is the index location actually, Nidhi.
Okay,
Right?
yeah.
So if you look at the index location, I'm just looking at this table, which was a table from the above. The first probability is 74.25, right? The first prediction is 74.25, and that's what it should be looking at. If I come down, 74.25, right? So I'm saying grab the very first observation, show me the probability, but I'm rounding off to the 3 decimal places, right? So that's why the probability is 0.742258, correct? What is it that we are doing over here? Exactly. So we are saying it's basically an array, right? So this is the NumPy array indexing. So we are saying first row, Python indexing begins with 0. First row, second column. So first row, second column is this guy. Everybody sees that from the original table, right? Now what are we doing over here is basically we are looking at this as a test case. And we are saying test case 1, which is from this array. Now this is the position, which is 0.258. If it is, tell me whether this is more than 0.15. What do you think is the correct answer? True or false? True, right? Because we are saying this array, look at the member sitting in this location and tell me whether the probability of that being more than 15% is true or not. So the answer is true. Now, what it tells you is that instead of using a 50% cutoff for defining one, so earlier what was happening by default was we were saying that only if your probability of survival is more than 50%, I'm going to call you a survival. Now I'm lowering it. I'm saying even if there is a 15% chance that you're going to survive, I will classify you as a survivor, right? So it's now going to give more survivals actually, because now I actually lowered the threshold and I want to detect more survivals which are happening. So I'm lowering the threshold to 0.15, right? And what we are doing is we are creating a brand new array compared to the predicted use the default of 50%. Now I'm going to use a default of 15%. That look into the predicted probability array that we've got. Look into all the rows. Column means all the rows. One means the first, the second member in the column. And if that is more than 0.15, do a Boolean comparison, true or false. So it's going to do that comparison. It says true, 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 false, 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 true, 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 false, 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 right? So now basically what it has given me is now I have practically changed the threshold from 0.5 to 0.15, right? Let's see what happens now. And then I'm recreating my classification report with original actual data and this with a threshold of 0.15%. And look what happened to the recall, 80%. So I already gave my business what they required, right? So they told me that at least you must be having 70% recall. So I played with the threshold and I actually fixed that recall. So now what is the interpretation of 80%? Who would like to tell me? 0.8. The model is able to correctly find out 80% of the survivals, right? And you can see it's more leveraged for this one because I have on purpose went and changed the threshold for one, right? Because my business told me that you have to fix the one. I'm okay with the zeros. I don't worry about the non-survivals. I have to detect more survivals because my objective is to rescue these people. So build a model where I can actually detect more of them. So you can see all the other numbers are weakened, right? I mean, they are like worse than what we had originally, right? If you don't remember, I think I have the table over here. So you can see 0.78, 0.89. So this one has slightly improved. This has gone down, recall. This was 0.73, 0.57, and 0.55 to 80% recall. So we have improved that. So I'll just wait for you to run this. And let's see who can tell me what should be the threshold for getting the recall to 90%. So let's say now the managers tell you that you must build a model which has a recall of 90% minimum for class one. And you can play with many, many different things. But in this case, you're only playing with the threshold. Can you tell me what threshold will give me the 90%?
Zero.
Maybe
That's
point,
hmm?
0.5 or something.
Zero.
Oh, sorry, 0.05.
0.05. You've already run, Nidhi?
No.
Okay, fair enough. Others, you can also confirm. So just rerun the algorithm and
You are
tell
saying
me
minimum 90%, right?
minimum 90%.
Then put zero simply.
Zero?
But
Threshold.
zero will bring recall as 100%.
I don't want like, I mean, that absolute. I'm saying just at least like, just
Maybe
the right threshold for giving me this one.
the point bit something between 0.1 and 0.05.
All right. Okay. Awesome. Let's hear from others whether you agree,
Where do we
disagree.
have this code on the code which you ran? Do we have on the blog?
No, it's not there in the blog actually right now. I will type it in, but right now you can just, that's why I'm actually working on this example, baby example, right? So I just, you can copy paste from here only. So predicted probability is the actual probability, not the classes, right? So I'm working with the actual predicted probabilities to do my own classification. And then I was looking at the first row, entire values for the first rows, and I rounded off to this. So let me know once you're done with this, then I can move on. So I'm just showcasing what we are doing actually, right? And then people can create for loop also You can play with many different thresholds. There are some existing codes online that you can leverage as well, right? So that will talk about the threshold optimization, where you can actually like slice through the many threshold values and see how it does the precision recall for me, which is then you can choose what is the right threshold for me. And that will automatically be happening in the auto ML that I'm going to showcase in the last class using H2O. Hmm? Predicted prob is what we did in the prediction, right? So this is the one. Which is dot predict proba. Basically, that is the function that we use. Right? Don't worry about the grid right now. Grid is the random forest, but just have your tree, right? Whatever trees that you are using, and do the predict underscore proba, right? That will give you the predicted probabilities. Once you've got the predicted probabilities, then we will run this one that I was showcasing. Right here. These three lines, 62, 63, 64. In fact, 65 as well, just for your understanding.
Sir, can you go to the other line where we are calculating predicted prob?
Okay. So let me just grab it and put it here only. Basically, let's say I'm looking at the predicted probability, right? So predicted prob is but your instance. So I think in this case, it is grid, I'm calling it. And then you're looking at, how come it's not giving me any clue? Okay, yeah, there you go. And then you pass on the X test, X underscore, or was it what, sorry, how I'm naming there, does anyone know? Yeah, there you go. There you go. That's the complete code.
You mean saying grid is not defined?
Grid, that's what I'm saying. I mean, you use your tree object.
Okay.
Grid is what I'm using for in this code, but you use your own tree object that you've created. Just do dot predict proba, which is the
Yeah,
method
got it.
to, yeah, okay. So 78, line 78 to 81 is what you have to type. The purpose of lines 79 and 80 people is just to show you one example of how it is working. It's not necessarily needed, just to show you one example of what you're doing. And then we're going to repeat that for the entire array. The entire array is this array, which is the predict proba or predicted probability. We are saying go ahead and run this logic, which is select all rows. Colon means all rows. This means basically the first member. That means this value, because this is the predicted probability for 1. So we're saying go ahead and make a check on all rows for this value. And if this value is more than 0.15, please do a true and false for me, Boolean comparison, right? And that's what it is going to spit out for you. True, 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 false, 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 true, 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 false, 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 like that. Now, how did I decide 0.15? That's the trial and error, right? You can try different values and we can try different values and you'll see what really happens, right? Let's say I try 0.25. I don't want to be that bullish. I'm just going to say if the predicted probability for class 1 is more than 25%, go ahead and put them as a 1. I don't want them as a 0. Go ahead and put them as a 1, right? So let's go ahead and run this. So now I mean, it will be hard for you to know which of these values changed, but it will be evident when you're running the report. Now you can see I haven't really lost a lot of things, right? I mean, did it run or no? Yeah, it has run. So even with the 25%, I mean, recall is quite decent. So let's go ahead and change it to 0.3. Now it has dropped. So it seems like somewhere between 25 to 30% is a good mark to have, right? But I'm going to stick with, let's say, 25%. So as long as the probability of somebody surviving is more than 25%, I would like to classify them as a potential survival. That's a good enough risk for me to have, right? So, and using that, now you can see my recall is 80%. So we just addressed that need that the business had or your stakeholders had.
Recall 90 is coming with 0.1.
In your case, it's 0.1?
Yeah.
0.1 what?
0.1 threshold.
Um,
Survival recall is coming as 91% with threshold 0.1.
okay, got it. Okay, so even better. Are you done, people? Or are you still working on it? Amit, done? Which one? This line? Yeah, you can stop me if you're not completely up to the speed on any of these areas. It is not necessarily overfitting, but also how to selectively modulate one of these numbers. What will happen? Can somebody try me if I have to increase the precision for 0? Increase the precision for 0. What should be the threshold? I mean, it should go higher or lower? And what will be the change in the code? What do you think? Right now, I just told you that I improved the recall. It's a quiz question. I'm not expecting you to be doing it in real world, but let's say I want the precision for 0 to be 100%. Tell me what is going to be the threshold based on this math. What is the number? What is the change in the code? Precision for 0, I need to make 100%. Tell me the code that I need to run on this one. It's going to be some trial and error, but let's see if you figure it out. There are 2 changes you have to make. I'm giving you the hint. Not just 1 change, 2 changes you have to make. Which one? Here. Line 79, yeah. 0, 0. Okay. But that is just a test. Only change you have to make is in line number 91 actually, because this is where the magic is happening, right? So that was just to showcase. You're right. I mean, something needs to be changed in those lines, but only changes in line number 91. 2 places you have to make changes in line number 91. So tell me what change I have to do. I'm just gonna copy that line so that anyone knows the shortcut for running. There you go. Perfect. Okay, now tell me what changes I have to make. Comma 0. Colon. Comma zeros. So what does colon mean, everyone? Anyone? So basically, array is 2-dimensional object, right? So how would you know this is a 2-dimensional array? Who can tell me? Even without doing the shape. Sorry. The telltale sign for the arrays.
Every bracket containing 2 values.
Yeah. So the telltale sign for array is the number of square brackets that you see. So if it is having 2 square brackets and 2 ending square bracket, that means a 2-dimensional array. So when we are saying look at the all, that means the first dimension, which is the rows. So I'm still scanning through all the rows, right? So don't get confused. So I'm still scanning through all the rows. Let's come down. I have zoomed in too much. That's why I have to go up and down so much. So over here, all the rows, but instead of looking at the second column, which was the predicted probability of class 1, I want to look at the predicted probability of class 0. That's correct. So what you have suggested is correct, right? Now, will it work or no? 0.25%. I don't know. Let's try it out. Let's see if it brings me to 100%. What happened here? Something got really messed up. This looks very, very bad actually. I don't know what happened. What did you do? Let's do 0.5. Yeah, why not? Which is the default. That's always a good way to recreate what we had originally. Oh, I don't know what is happening actually. We should generate a confusion matrix as well for this to just to understand what is happening. Because this should be ideally related to your original data, right? Anyone who would like to troubleshoot? Tell me what we are doing wrong. Otherwise, I'll have to rerun the code. Let's run this. Okay, so this is working. So there's definitely something in the threshold that we're using, which is not correct, right? So I was just able to get back to the same level of the table that we had originally. So what really it means is that this is having some bogus values, or I mean some values which are actually creating some havoc with the data. Let me think about it. Predicted probability, all rows, first column is more than 0.5, more than or equal to 0.5. If that is the case, let's do this actually. Sorry, I think it just becomes a slightly interesting problem. What is happening? Let's just spit out the predicted probabilities here so that we know what changed. This is how the table looks, predicted probabilities. 0, 1, 71, 28, 88. So these are the predicted probabilities, right? 30, 0, 1, 88. Okay. And we were looking at this observation over here, 0, 7, 4, 2, 5, 8. So that probability itself has become different now. No, that is there. That is correct. So that is correct. So 74, 25. That's okay. Yeah, let's continue now. And we will go down 74, 25. So right now it is being classified as a 1, right? I'm messing up maybe the direction of the change over here. Now we are changing this. If it is more than 0.5, go ahead and classify that as a 1. And that is what it is doing, right? So it's classifying as a 1. Now if I regenerate the table, wow. I'm gonna go the other extreme. Yeah. I was hypothetically talking about how to make the precision for 0 to be 100%. So that should be, oh, okay. Anyways, I think we'll leave it here because it's becoming a little bit hypothetical right now. I think something to do with the direction. That's where you have to experiment with the probability number over here, but it's not liking it for whatever reasons, right? None of these numbers are actually making sense to me. And I am sure I'm messing up something in terms of the direction of the impact. Okay. Shall we park it here? But at least you get the idea on how to do the threshold optimization a little bit, right? And we can figure out this direction part later on. Now, what we're going to cover is very, very important concepts. I'm not going to go to the random forest. I don't think we should be able to cover that ensemble today because you have to do the class submission as well, which I will leave it to you. What we're going to talk about is a couple of different other optimization techniques, which are cross-validation and hyperparameter optimization. Does anyone know what is a cross-validation? Have you heard about it? Cross-validation? No? No? Yes, no?
Yes.
Yes meaning you have heard, yes meaning you don't know. Or none
Yes,
of the above.
no, yes, I know that.
You have heard, okay, that's fine. So I will talk about the cross validation, but before I do that, I will create a blog, folks. I mean, I just don't have time to do it, but I will just share one link with you and see who would like to help me understand. Only one chart I'm going to ask you, only one chart, this chart right over here. So I'm going to share this link. Let's see who can understand based on the write-up what is there in the official write-up, and tell me what do you think this may mean, right? Did the link go through? No, now it would have gone through. So I'm only looking at this chart right over here. And this is the concept of the cross validation. So go ahead and take a look very quickly and let me know what you find out. Who would like to explain? We'll wait for you till about 5 minutes and then you can tell me.
I can explain now.
Let's give others also the opportunity, Krishna.
Okay.
Otherwise, it won't be fair for others. But we'll come to you first, Krishna, since you raised your hand.
I was trying to code something similar to this when you said to find out different thresholds.
Right. Okay. Awesome. We'll discuss that.
Not exactly CV, but I simply created an array with possible values and of thresholds, and I just iterated it over it.
Understood.
Yeah.
This picture tells you everything about the cross validation. If you can just follow the colors.
Yeah.
And there are many, many ways of doing the cross validation, but I'm just going to talk about this.
I'm looking at the training data again and again, find out which is the correct parameter to get the finding parameter.
Finding parameters. Okay. All right.
So
Yeah.
one of the ways, obviously,
No, ignore the finding parameters part. Look at the colors. Look at the folds. Okay, I will probably explain. And sorry, Krishna, you want to go first because you wanted to jump in?
Sure. So here all the available data is been broken into train and test. Test was then never touched, and the training data has been broken into 5 folds.
Yeah.
5 equal folds. For each iteration or for each epoch, only one of the fold is kept separate and trained on the 4, and then one was used for the validation.
Correct.
Then in other epochs, this validation set has been rotated. So similarly, it covers complete data for rotation, complete data set for validation.
Absolutely.
In a mini batch.
100% correct. Thank you. And that's why you were saying, okay, I can explain now because you knew the concept already, right? So, right. So I'll just explain what it is, right? And others should not feel bad, that I don't know. That's why you are here, right? So I'm just going to talk about that. Okay. There it is, right? So what is a typical modeling approach that we've been following? You begin with all data. Then what you do is, let's say you do 80% training and 20% of your test. Everybody knows this method that we've been following so far, right? That you take your original data, which is 100%, and then you break it down to the training and the test. And this is where you build your model. on this entire data, you train your model. And this data, you test your model, or you generate your statistics whether the model is good or not, right? This has been the traditional approach that we've been following. This is what we call as a CV approach, cross-validation approach. What happens in the cross-validation approach is, in this case, we are doing what we call as a five-fold cross-validation, right? What it means is that your training data will then be taken and broken into 5 parts: 1, 2, 3, 4, 5 equal parts. Your training data has been broken. And then what will happen is 4-fold out of the 5 folds will be used to train the model. And this will be used to test the model. Similarly, over here, this data will be used to train. And this data will be used for testing. And then you can see the flow, right? What is happening in this? That your entire training data has been used for training and testing, right? So basically what is happening is you're building a more robust model. You're trying to minimize the overfitting, build a more generic model, right? Because right now what has happened is that your data has only seen, or your model has only seen this data and then asked to make the prediction on this. This data asked to make the prediction on this, right? So basically, let's say I'm generating accuracy number. So in this case, accuracy comes out to be 71%, 72%, 70%, 72%, and 70%. So overall model accuracy will be nothing but the arithmetic average of these numbers, right? Because that's how the cross validation really works out. So it will be reporting that the overall accuracy of this model is this. What happens is, as a result of that, your models are more robust and they are better fitting. So overfitting is less, right? Generally speaking. And if you don't have the luxury to split your data in the test as well. So let's say you have very limited amount of data and you want to use all the data for training and use all the data for validation as well, then you can get rid of this test also. You can run the CV directly on the original data. But what is happening is now you're actually leveraging the entire data, building the model on the entire data, and testing the model on entire data. But you're doing in the tranches that when you're building one particular model, that model does not see the data where I'm going to do the validation. Then it skips through and then look at another set of data and then does the same process. Is the concept clear? Everyone? Yeah? Amit, Aditya? Huh? All good? So that's the concept of the cross validation, right? Most of the models that you will build in the real world will be cross validation, will not be the train test. They will be the train test, but you'll do the CV on the training data because this is a more robust way of building the model, right? So then I'm gonna, I'll ignore this section, which basically gives you the scores, right? Now it's a good time for me to talk about some of the other levels of what are the main parameters in the tree. So there's a one parameter called criteria, Gini. What does it mean in the tree? Criteria is Gini. Default value is Gini. But you could also test with the entropy. So which one do you think will be better? We don't know. So let's say I'm going to test both of them with the Gini and with the entropy, which tree gives me the better value. Splitter best, you can ignore that. Max depth. What do you think is the max depth parameter in a tree? Right. Max depth is this. I'm gonna, if I can, yeah, this desk is too small for me to have that many things. Depth of the tree is nothing but this. And that's, I'm actually combining all of them to give you the most optimal tree. So this is the root node. Another node, basically the child node, and another node, right? Yes, levels of the tree. Basically, this is what the depth of the tree is really, right? And then another node, right? So the depth of the tree is basically, this is what happened, folks? Something fell down. Acha, charger. So one level, two level, 3 levels, right? So that's the depth of the tree. So how deep your tree will go from the, not counting the root node. Root node anyways you're gonna have. So when you say depth of the tree is this, that means how deep I want to go. So if I ask you the question, how many levels shall I have in my tree? The answer is I don't know. So I'm gonna test out all those levels in a systematic fashion, which is right over here. So I'm gonna try out a tree which is 5 level deep, a tree which is 10 level deep, 15 levels deep, 20 levels deep, and 50 levels deep. So 50 level deep tree, imagine Titanic data is not that big, but I'm saying, okay, go and get completely wild, have 50 levels, which is like, not needed. For bigger data, maybe you need it, but for Titanic, you definitely not need it, right? Maybe probably I can try a slightly lower level. So like 3 level or 4 level or 5 level, but I'm going to try that, right? So these are the 5 levels of depth that we're trying. Criteria we have already spoken about, whether you're going to split the tree based on Gini or entropy. I don't know which one is better, so I'm going to try both of them, right? Min sample leaf. Min sample leaf. Can anyone look up the guide that I have shared with you, or the sklearn dictionary, and tell me what is the min sample leaf? These are the 4 most important parameters in the tree. What is the min sample leaf? Your guess after reading that. Hmm? That sklearn, just put sklearn decision tree, like this one. You'll get it right. So just read through what is the min sample leaf and tell me what do you think this means. Hmm? Leaf is correct. So Chirag is correct. Leaf is which nodes which don't have further child nodes. But what does the min sample leaf mean? Exactly right. So Amit is right in this case. So min sample leaf is like the end nodes. Let's say this is what my end node is. End node, or basically the leaf node, because leaf cannot grow the branches, right? Leaf is the end node. So in this end node, I want to have a minimum of 5 observation, minimum of 10 observation, minimum of 15 observation, minimum of 20 observation, right? So you're controlling, like, for each of the nodes that you're gonna have, what is the bare minimum sample size you must have, right? So that's what I'm actually trying over here in this, where I'm saying min sample leaf. So you can have a leaf which has only 2 members, minimum of 2 members. They can have more, minimum of 5 member, minimum of 10 member, 15, 20, and 25 members, right? So that way I know like how exactly which setting is gonna work the best, right? So that's good. So we've just covered 3 parameters. The last one is min sample split. What does that mean? Again, look at the dictionary there and tell me. Min sample split. That's exactly right. That's exactly right. So min sample split meaning, like if I'm looking at this and let's say this is going to be split further. So I'm saying if you have, let's say my min sample split is 50. So you can split only when you have 50 or more. The moment I have 49 members over here, I cannot split it. So it's basically a stopping criteria for the tree. These are all stopping criteria for the tree, right? So you're saying you can split as long as you have 2 members, 5 members, 10 members. If you have 1 member, anyways, you cannot split, right? One cannot become a fraction. So as long as you have 2, it can theoretically split into 2 other parts, 1 each, right? So we're saying as long as you have 2 members, you can split for the 5 members, split for the 10, split for the so on and so forth. Now, if I were to try a tree with all these settings, these are 5 levels, these are 2 levels, these are 6 levels, these are 6 levels. How many trees we are supposed to be building? 5 times 2, because all the combinations you're going to try. 5 times 2, which is 10, 10 times 6, which is 60, 60 times 6, which is 360. So you can take your day out and build 360 tree and then come back and say which one is the best setting, right? But nobody has time, or I mean, that is ridiculous, right? So that's where this grid search really comes in. Grid search will do all these settings for you, build a model, which will check out all the settings and give you the best possible score, right? This is the code where it's gonna happen. I'm gonna share that code with you so you can type it in, but I'm just gonna tell you what exactly it is, right? So there is a package called as Grid Search CV. What do you think this may mean? Grid Search CV. It's searching through all the combination and it's gonna do the cross validation on top of that, right? You are looking at my tree, and my tree in this case should not have any of these levels. So you're gonna go with the plain vanilla my tree. Cross validation is 5-fold. Scoring is recall. So what do you want to really optimize for? So you can tell I want to optimize for precision, I want to optimize for recall, I want to get the accuracy higher. You can specify that. So I'm saying try to get the recall as high as possible. And when you say scoring, recall, you don't have to tell recall ko maximize karna, because that is understood, right? That recall needs to be the highest. So it will automatically figure out what is the best setting for the recall to make it higher. And then I'm gonna pass on these parameters, which is max depth, all the levels I want to try, criteria, all the levels I want to try, all the levels I'm going to try, and it's going to run this on the train data. And what it is going to do is it will tell you which are the best settings. So you said you wanted to try Gini and entropy. I'm telling you that Gini is the criteria to go for. You wanted to try different levels of depth. 5 levels of depth is optimal for you. Don't go anything beyond 5, right? You want to try different sample leaf, like how many minimum you should have in the sample leaves, and 20 is the best criteria for you, and 50 is the best criteria for you to split further, right? So that's what basically generates, right? And then you'll see we will create some other data and all of that coming out from that. But I think I have messed up certain things in between, so I'm just going to fix the code very quickly, and then come back to you, and then you can copy the code and run it, and then I will turn it over you to run the assignment. I think what is going to happen now, I should not be using my tree. I should be using something else, right? Because my tree is already this. My tree is defined over here. I cannot be using my tree. So I'm going to do this. I will recreate my tree. And you can copy paste with me, folks. I mean, this code that I'm working on. This is what we mean by hyperparameter optimization. We will not be able to cover the random forest today, but definitely we will talk about this and give you the assignment to work on. So let's come down. Okay. So, oh, okay, I'm initiating that. So that's fine. That's fine. Then it's okay. So over here, you can start copying with me. Forget about the max depth and all of those things. We are not doing that. Random state is 99. What does the random state mean? Anyone? Why do we need this random state?
Is it for reproducibility of the model?
That's correct, Krishna. So it's just basically if I want to rerun the model, or if I give it to my team members and they want to rerun the model, right? You will see that they will get slightly different result. But if I anchor it to a particular random state, it could be any number, 99, 0, 999, 1, 2, 3, 4, 5, 6, your choice. But if you say, take that random number, it will remember the settings that I actually used in terms of building the tree, and then you can recreate that output. Otherwise, if I don't have it, and if I run number of times, you will see my results will slightly vary because of the initialization and how the algorithms really optimize, because ultimately it's an optimization algorithm, right? So you just want to say, please take the same path. If you want somebody to go from here to Kurg and achieve exactly the same time as you have done, you'll tell them, go at this time, follow this path, avoid this, right? All the things, right? So exactly the same thing we're telling the model, that go and follow this path for optimizing the performance. It doesn't mean, it could be any number. right? So let's go ahead and write this line, people, everyone. Let me know if you're done. So I'm reinitiating my tree. I remember I'm not passing on any depth, anything like that. The only thing I'm passing on is class weight is balanced and random state is 99. Then I'm creating my list of parameters that I want to optimize for. So I want to try the, let me do this actually. While we are at it, I want to see what happens. I want to try 2 levels of depth as well, 3 levels of depth, 4 levels of depth, because I never tried that lower numbers, right? So I'm going to try these many depths now. 2, 3, 4, 5, 10, 15, 20, and 50. Probably I can remove 20 and 50. That's ridiculous. Even 15 for that matter. I'm going to try these. 2, 3, 4, 5, and 10. Yeah. Everybody's clear online, people, what we're trying here? We're trying to get the best settings for the decision tree now. Till now, we were building the plain vanilla models. Now we are saying, okay, I am now going to focus on generating the best performing model. Let me know once you're done with the line 120 also. You have to type it in manually. Huh? Yeah, we will do that in the line below. Right now, we're just creating some objects. Can anyone tell me what type of objects these are? Hmm? Sorry, I hear the word, I don't know who's saying. List, yeah, that's correct. These are lists, right? So we're just basically creating the NumPy lists over here and storing them. So you can see it's automatically telling you that I'm a list, right? That's the beautiful thing about the collab. And it's also telling you that I have 5 items. I am a list and I have 5 items with these values, 5, 10, 15, and 20. Sorry, I think this is slightly outdated because I haven't run it. Now it will tell me something different. Now it is refreshed, right? So it says I'm a list. I have 5 items and my values are 2, 3, 4, 5, and 10. Correct? By the way, these spaces don't mean anything in Python, right? So you can do that, but it just looks ugly. The code will run fine. And when you prop open the help from the list, it will not follow your bad coding practice. See, it says I'm still a list and with the well, structured or indented code. Are we good? Done? Shall I move on to the next one? Or you're still typing? I think some of the folks are still typing. Amarnath? Done? Amit? Still working? Folks online, shall I move down then? Yes, no?
Give me 1 minute.
1 more minute?
Yeah.
Okay, sure. Let me know.
You're done.
Okay, cool. This is where everything is coming together. So this is a long code. I'm gonna give you time. Let's see if I can zoom in so that you can see better. Okay, there you go. Sorry, I don't think I have shown you how to import the grid search, right? Did we import that somewhere? I think, huh? Where did we import? Over here, yeah. Okay, yeah, perfect. Yeah, it's right above that, right? So you have to import from sklearn model selection, import grid search, CV. Grid search is like all the combination. If you cannot afford to run all the combination because certain algorithms and certain data will be too much time consuming and resource intensive, or as we call as the compute, they will be too heavy on the compute. There is another one which is called a randomized search cross validation, which will just randomize the selection among all the settings that you're looking at. You can try that as well. But because the data is small, I can afford to do all the possible settings, grid search. Now, this is going to be a trick question. In line number 52, ultimately, how many models you going to build? Rashmi may know the answer from the last class, but others, huh? Yeah, three, 6, 360. But what about the cross validation? Remember, each model is now split into 5 parts. So 360 times 5, that many models it will be building. Because based on the parameter settings, we're looking at that many 360 models as Steve also is talking about. But then each model is now built 5 times because of the cross validation, 5-fold cross validation. So we're looking at 360 times 5. You can have a 4-fold, 3-fold, 4-fold, 5-fold, any fold you want. Generally, 5 is the standard. 3 is also good. Done, everyone? Or still typing? I think people are typing. Hmm? Some indentation error will be there. There? Wait for it, you're getting the error. Let me run it. So this is line number 122, 123, 124. It's running for me, so I'll tell you. You're not getting any error? Okay, so I think some typo somewhere. Yeah, I didn't get also any error. So there will be some typo. So when I say my max depth, this is the name that you are giving to your list. When you look at this max depth, this is the tree internal parameter. So make sure that there's no confusion. So you're saying basically, min underscore samples leaf, right? You have to get this one 100% correct. This is the tree internal parameter. Then you're saying this is my list. Some typo somewhere. Working now?
For me, it is saying I have picked a class weight random. So it says it should be balanced.
Yeah, we did the balancing here. Here, class weight balanced.
Okay, I put it random. Okay.
Everyone, it's working now? Amit?
Yeah, working.
Okay, awesome. So basically, then when you look at this output, it says that you have tried these parameters: class weight balanced, random state 99. These are the different settings you want to try out, right? So it just confirms that this is what my understanding is, that you wanted to confirm. I said fine. Then go ahead and give me the. I think we are doing in slightly reverse order over here, which is fine. I'll come back to this code. This line, what do you think this line gives? Right, so go ahead and write it out. So if you do grid dot best underscore params underscore, it will tell you the best setting. So remember, I went lower in the depth as well. I tried 2, 3, 4, and all of that. So optimal still comes out to be 5. So it confirms that 5 is the right number for you to have. Yeah, that is true. I mean, very convenient. Slightly it will be there because you'll see that there will be 2 or 3 models which will be tying out. They have exactly the same score to the 5th place. So I'll show you that in a minute. Don't be surprised. You will get something slightly different.
Sir, why the class weight random was not good?
Random is more like, for not giving any special weightage to the underrepresented class. Balanced is more looking into both of the classes simultaneously.
Right. But the surprising thing was when I was trying to compile the model, it gave me error that valid values is balanced and not random.
Okay. So just
And I
leave it
have to
alone.
change.
No. So rather than doing anything over here, just remove the class weight. That
Yeah.
also you can try. Just remove it and run it with that.
Now it's fine. When the first time I ran it with the random word, and it
Uh-huh.
prompted me that I should be changing it to balanced.
Okay. Okay. Got it. Yeah. So just basically giving as a good practice. But if you don't want that, just remove it.
Okay.
Okay. Now we will go to the next line. Yeah, let me run this line and then interpret this, then we will come back to it, right? So what do you think this line is doing, anyone? Line number 128. Huh?
Whatever result is coming, making as a data frame
Yeah,
and then put it in a CSV.
that's correct. Yeah, that's correct. So we're just saying grid is the object that we have fitted with the grid search cross validation. And then dot CV underscore results will basically whatever you have fitted, show me that results, right? I'm creating a data frame out of that, and I'm calling that data frame as results. Then I'm exporting that data frame to a CSV file and naming it results.csv. And then we're going to look at that CSV file. That what did you really build? Are we good? So where is this file going to be located?
Jupyter page location.
Google
That's correct.
Colab.
Yeah, so it'll be in your base location. Let's see if I can show you. So if I just do pwd, content, right? So it's basically the same location, which is, I think, this folder right over here. And you can see there is a file called results.csv, and I will click on it and download. And this is the third time I'm downloading the results. So let's open it. And that's how your results look like, right? So remember I asked you how many models you're going to build. So if I just highlight that, it says 360 models, right? So those are the number of iterations that we're going to have. But each of this model will be separately built 5 times. for the cross validation, and I will show you the results of that cross validation as well. There we are, right? So the cross validation results are over here. So model first, model second, model third, model fourth, model fifth. Remember, Python always starts with zero indexing, so don't get confused. So this is the first model, second model, third model, and I killed the file. I don't know where it happened. There you go. First, second, third, fourth, fifth model, right? And this is the score that we get. So let's look at one line, for example, what it means. It says for me to fit a model with 5-fold cross validation, it took me 0.0003 seconds. Standard deviation of fitting time, score, all of that, right? And what parameters did I try? I tried these parameters. Basically, you can see there is a dictionary here. I tried these parameters. Gini, max depth is 2, min sample is 2, min sample split is 2. I tried these parameters, right? And then I got the average score of 0.73. And that's where your point, Amit, comes in, that how come my model is looking different. Look, you can see like these many models have identical score. So it could just say, you know, whatever it fitted first, the very first model it fitted will be the model that is going to pop up for you. But you can see these many models have identical score. And they have slightly different settings. Let's look at what their settings are. Most of them are using Gini, or all of them are using Gini. So Gini clearly wins out compared to the entropy. All of them have the max depth of 2. All of them have min sample leaf of, most of them have the min sample leaf of 2 and 5 and 10, and then this. But hold on, didn't it say that the model is different there? If I remember, it said the best parameters are Gini, max depth is 5. So how come it's giving me max depth of 2 there? That's slightly weird. Did I miss out something? Okay, let me just, maybe I'm not rank ordering that data. Sort. I will do the sorting by mean test score, largest to smallest. Ah, okay, that's the reason, because it wasn't sorted out correctly, right? So here you go. So still now you can see there are two models which are tying. These two models which are tying, right? They have a score of 80%, 80.57%. Let's look at their setting. Sorry, it wasn't rank ordered. So Gini, max depth 5, max depth 10, minimum sample 2020. So basically it says if you do 5 max depth or 10 max depth, it doesn't really matter. You're gonna get the equally good model. So why would you do 10? You will just do the 5 if we are getting the same good model, right? And that's what basically it comes out. So let's interpret the line. So it says basically how much time it took me to fit, what parameters I tried, and so on and so forth. And then cross validation score. So for the first cross validation, this was the score, second score, third score, fourth score, fifth score, and then average. So if you look at this and look at the average, that will be this number right over here. That's the average score. And that is what is being used for bubbling up the model. Now you can see it's correctly ranked order. So it says you have two models which are ranked 1. There is no rank 2 because there is a tie. So between them, you decide which one is 1, which one is 2. Third, fourth, fifth, sixth, seventh. And then there's a tie again on the 6th place. 4 models come out equally good, right? That's how basically your models are generated. So I'll take a pause over here and see if there's any questions so far from anyone. Absolutely. Now let's go ahead and run the grid again. So now you can see the recall has become better, but not that much better. Still, I mean, there's room to go, right? Which one? Yeah, you can go ahead and type it in, then we can do it. Yeah. Others, you done? Here only, in your machine only. So it's using the compute power of machine basically. Packages are stored on the cloud. They're not stored on your machine. They're stored on the cloud. But actual compute power, which is used to generate the model, is your machine. Yeah, not using the cloud. Unless you change that in the setting that I showed you, the runtime. So for example, you can change the runtime. So right now it's not using any hardware accelerator, their system. If you select GPU and all of that, then it's going to use it. Okay. So let's generate this table. So instead of using the tree, I will use grid as the object, predict, xtest, and then regenerate the classification report. So you can see it did improve the recall performance somewhat, but probably not necessarily that much. Are we good with the classification report? Then let's do the feature importance, right? I don't think we have talked about the feature importance yet. Yeah, it is here. So from the grid, I am saying dot best estimator dot feature importance and rounding it out to 2 decimal places. Then I'm doing the feature importance sum and I'm displaying what were the features that I've passed on. So I'll take a pause over here. First, let you type it in and then let's see if anybody can help me understand what these really mean. What is the most important feature? What is the second most important feature in prediction of who will survive? Everyone has the output? Are you working through it? Then Now done? Anyone who would like to explain which is the most important feature? And what does these number really mean? 0.18, 0.65, 0.09, so on and so forth.
I think 0.65 is for gender, so that is important, where we can divide the data into male or female. So the impurity will reduce heavily on the first level.
Yep, absolutely.
Same
Yeah.
way we can read for others.
Second most important is passenger class. So basically what it means is that the two most important variable to tell whether a passenger is going to survive or not. The first most important variable is gender. Females survive more than males in this case. Then passenger class, right? Whether you're traveling first class, second class, third class in that ship had a consequence, right? Rich people survived more. So if you're a female, but a poor female versus a rich female will survive. Poor female will not survive. You'll see that coming in when we do the tree again. Then age. And these numbers add up to 100%. Why are they adding up to 100%? What is the significance? That's why I'm actually doing adding up all of them to 100%. Anything when it adds up to 100%, you can always translate it into percent. So 65% of the model performance is driven by gender, or 65% of the model's prediction is driven by gender. 18% is driven by passenger class, 9% is driven by gender, age, and then other variables like a fare and which town they embark from, right? Some of those, right? So those things are there. But let's do this, because now we know that this is the best criteria or best setting. I will take it back and rerun this tree right over here where we actually said, don't worry, we will try to get the best possible settings. I'm going to rerun that tree and visualize that tree, how it looks like, right? So this right here, I'm going to overwrite all of that with these settings that it gave me, right? Just make sure there's no typo, otherwise it won't work. There you go. So what we're doing is, yeah. So we have to go and run one more time this tree. Max depth is this. Min sample is this. Min sample split is this. Class weight is balanced, right? So criteria is Gini. Okay, you know what? You don't have to have the columns over here. Yeah, I think because it's I grabbed it from there. That's why I was getting confused. So you don't have to have the columns over here. It was making it look like the text. That's why I was wondering what is wrong. Now it should work. I think so. Let's run. Let's see. No, there is a typo somewhere. Huh? Ah, right. Max depth is equal to 5. Criteria also will be the same way. Will be equal to 20. Will be equal to 50. And will be equal to Gini. Okay. Criteria will be Gini. Max depth is 5. Min sample is 20. Min sample is 50. Yeah, that should work. There you go. Right. This is now become my tree, and I'm just validating the results, but I'm more interested in the visualization, right? So I'm gonna fit that tree, predict that tree. I will skip the probability part. Evaluate the model performance. Confusion matrix. Right. All good. This is where we would like to plot the tree. Okay, so now you can see this tree is so huge that we cannot even see in this window. So what we're going to do is come down, if it lets me. Just very, very big tree. And that's what makes it very difficult for us to navigate. So, but I'm going to do the saving of this tree. And that's what we will pull up. Okay, so it's slightly more interpretable over here. So you can see the first criteria that it used to split the tree. And again, you can see the Gini is 0.5 over here. Um, why 0.5? Anyone? Gini? Because we did the class weight balanced. So it automatically, huh? So it automatically balanced the data internally and says both of them are 0 and 1 are 356, 356, right? So that's what happened over here. In reality, we know it's not the same thing. And then it's saying if gender is less than 0.05, what does it mean gender is less than 0.05? In the dummy coding, what will be female? Remember we did the dummy coding, right? So in dummy coding, female will be 0 because it's alphabetical order, right? Female comes first. So F and then M. Female is 0. So it says basically if you're less than 0.05, that means if you're female, you are on this side of the tree. Survivals, right? And you can automatically see the survival is getting better as you're on this side of the tree. So out of 266 people, 253 survived. And if you're on this side of the tree, which is false, a large majority of them did not survive. And then it applies the cut like age and so on and so forth. But let's look at the worst possible nodes and the best possible nodes. These are the, I think the values are in decimal, so it's slightly less interpretable, but let's just read it, right? Probably this one. This is the worst possible node. Out of 269 passengers, 204 did not survive. And what are these people? They are traveling low fare. They embarked in a certain city and they are traveling second class or third class, and they are aged more than 9.5 years, and they are men. So men who are more than 9.5 years old, traveling second class or third class, not the first class, embark in those cities, and they are paying less fare. That means they are traveling actually lower class. Even then, they have the worst probability of survival, which is what we know based on like what really happened. So they said, okay, men in the last and people who were in the lower decks, they were not given a chance, or those decks flooded sooner than other areas, right? So that's what basically it means, right? Who are the best possible? Where is the best possible survival rate? How can I tell where is the best and lowest? I am looking at the color coding. The dark blue means higher survival. The dark orange means less survival. So they all look pretty similar, but let's look at the meaty one. Okay, let's look at this for example. So they are the ladies who are traveling second class or first class and are paying more than 30 pounds. And of course, we know from here the gender is there, right? So that basically sort of like, covers the entire end-to-end decision tree walkthrough, hyperparameter optimization, visualization, feature importance, all of that, right? Now I will give it to you to work on that lending club, not lending club, sorry, the data that we used last time, the German credit card data. Do I have that notebook open? Maybe I have it somewhere. No. So what you're gonna do is basically um, work with the German credit card to build a decision tree with the hyperparameter optimization and report your precision and recall for the defaulters. I'm only worried about the defaulters, right? If you don't have the recall of 80% for the defaulters, please optimize the code to get to that level. What are the most important issues to predict the default? Build a final DT with the optimized parameters and submit that along with your endings and HTML code. That's a simple assignment. You just have to replicate on that data, right? So whatever you've done, just do it for the Titanic, right? So work with German credit card data to build a decision tree with hyperparameters optimization, report your precision recall for the defaulters, right? So that's the first one. There are different parts. So the one is like, just do the hyperparameter optimization. That's question one. Question two is, or you may have it, I don't know. I mean, depends on the performance. If you don't have the recall of 80% for the defaulters, please optimize the threshold to get to that level. What threshold you chose and why? Okay, that's question three. Sorry, question two. Question three is, what are the most important features to predict the default? And question four is, build a final DT with optimized parameters and submit that along with your findings in HTML codes. What are your conclusions? Conclusions, right? And each one of these guys will be 5 marks. So total of 20 marks. This is an in-class assignment. You can start working in the same group, or because it's so simple, you can work alone also. All you have to do is to just point to that data. And this I'm actually submitting on the chat as well. So if you can create the link, Chirag, on the LMS for submission today. Yeah, all good? Folks online, any questions on the assignment that we're gonna do now? Data Chirag will share from the previous class.
Can you share the notebook which you were working on?
Notebook you have already typed, Nidhi, no? the same one that you worked on, just use that same one, but create a new version of that and just point it to German credit data. I don't have the German credit data over here. So just
No,
go
the
through the
thing is
same
that
flow.
in case I missed any of the syntax, then this could be the reference point.
I have done a lot of other things also, so I don't want to confuse you here and there, right? But do let me know if there's anything specific in the code you want, and I'll send you those snippets on the chat. Because I keep on iterating on the things here, so it may not necessarily go in the same flow.
Okay.
Just let me know what code you missed out, and I'll send it to you.
Okay, thanks. Yeah.
Which one?
After the base for
Huh.
itself.
Best parents, yeah. This one?
Sir, what will be there for the next class?
I will talk about that. But I'm just working on the code right now, just to make sure everybody is, yeah. Sorry, which one? Best parameters, okay. This one. Okay. For the like the final tree that we have generated. So we grabbed the best parameters from there. Then what we did was to go back to that tree because that's what I'm saying. I mean, I cannot share this because it's just like I have messed up certain things. So what you're gonna do is copy the same thing, like you have understood. Criteria is Gini, max depth is fine, min sample leaf is 20, and then pass on in that tree to generate the final tree. Nidhi, any particular line that you didn't have the code that I should send you?
Most of the code I executed. Yeah, I'm just thinking in case I missed.
Okay, sure. I'm here only, no problem. So we can take till about 5 for if you have any doubts and questions. Post that you can continue working from home, or you're more than welcome to stay here and finish it off. It's up to you. But around 5 is when you're gonna wrap up. But happy to take up any questions. Submission timeline will be around what, 10 p.m. today, Rashmi? Will that work? 10. Fine, folks. Tomorrow. Last time we gave till. Okay. Tomorrow 5 p.m. Yeah. But try to just go through it right now in the next 30 minutes. If you have any questions, I mean, I'll be more than happy to answer that. Up to you. People who want to go for the tea break, you can. Hello? Hello? Tea break. He will be there right now. It's 4:30. You can try it out.
What people I want to hear. What's what time? You have so many points and you are
Thank you. Yeah.
I really I mean I think you will be very good longer.
Yeah, yeah. Awesome. Thank you.
Forward because no one talks about all the time on the point. When you start discussing about different
Mm-hmm.
started discussing up then you go to work it then you the hyperparameter.
Yeah.
Then process it
Yeah.
to the hyperparameter.
Yeah.
All the aspects they will start when you are
Correct.
teaching a concept.
Yeah.
Then only
I've still missed out certain things. I mean, probably I can touch more on that, but definitely, I think good to have the perspective on some of these main ones actually. Yeah, absolutely. And this is really like, I mean, bread and butter
I
for
have
people.
attended lectures from I to yeah it's a very nice but they're they're more on the theory approach. Then they would take a problem and discuss life and see how actually actually because that's how
You have to bring in the.
because it's after all the execution, right? But whatever you do, it's execution.
I find there are two like extremes. People who just teach you theoretical, like the academics, like they'll keep on going into the formula, all the mathematical notations and stuff like that. The other people who will blindly run the code. They don't even know what this is and how that is, right? So that's where I mean you have to
That is the balance. Because that one people is just know the code. One people just know the theory.
Yeah. You have to have a combination of both to apply that in the reality. Good. Please everything. Come, you have to have it. Okay. People are still. Great. A lot of new folks have also joined in. Like, what's her name? Pavitra. A lot of new folks have joined in. 3 people. Hmm. Okay. Folks online, any questions, any code that is not clear that we want to discuss?
Recall is already more than 80% for default.
Okay, you're done with more than 80% of the code, right, Nidhi?
I have started, I have done till confusion matrix. So the recall is already coming more than 80%.
More than 80%. Okay, then it's not required. Okay, understand. And how much was it in the logistic regression? Do you remember?
No, I don't remember.
So just take a look at your previous code. That'll be a good data point to look at.
Yeah, will do.
COVID cases are increasing slightly. Around 4,000. We have to be careful now. I have gotten Covaxin. Yeah, Covaxin is slightly weaker as well compared to the Covishield. Not that like strong. In fact, today in my apartment community, they are doing a booster dose drive. So for the next time, KK, you were asking, I think, what shall we cover? So I'm just gonna put the links in the chat window. And if you can make a note, Chirag is not here. Eh? Chirag. So I'll just I'll just put the links what we're gonna cover for next time. Chirag, if you can also. So these are the ones, if you can note down, Chirag. PCA, we haven't covered PCA. So that's one. PCA will be article number, where is it? Article number 39. That's one thing that we're gonna do. We will look into the H2O, which is for the auto ML. Article number 51. Article number 52. These three. 51, 52, and 39. PCA, ensemble model, and H2O, because we're gonna leverage the H2O to build some of the auto ML models. Yeah. Hmm? Up to the people, group of two, max three, or they can submit individually as well. But they have to clearly mention whether this is a group assignment or individual assignment. In the LMS, when they actually put the notes, right? Like, I mean, comments, we should clearly call out because it creates a lot of confusion down the road whether somebody is submitted or not. So it should, let's say, we have Amit and Aditya work together, right? So they should just say together submission by Amit and Aditya. Or let's say Amarnath is working alone, then he should say submission for Amarnath. only. This file.
Sir,
Yeah.
what's the difference in question 1 and 4?
Question 1 and question 4. Let's take a look.
One
So this
says
is
with the
this is more about the working version of the code. Question 4 is when you do with the optimized parameters, and you have to highlight your conclusions and findings, some commentary.
yeah, and in one with the hyperparameter optimization.
No, they are both hyperparameter optimization. So the question 4 is like, I mean, remember how we did for the Titanic? We grabbed those parameters and then finally built one more tree with
Yeah,
those parameters. Yeah, so that's the part I'm talking about. And then what are your highlights? So for example, it will show you that these are the most important variables. This is how the cuts are happening, right? So then we can talk about what are the highlights.
and in one first I should be building a normal decision tree, and after that I should be trying to optimize the hyperparameters.
Yes, that's the first part. Second part is if the recall for default is not 80%, then how did you optimize that? But Nidhi is reporting that it's already 80%. The third part is what are the most important features to predict the default, which is the feature importance. And the fourth is build the final tree with those hyperparameters optimized. What are your conclusions with respect to the overall tree?
Sir, if in question 1 I do a hyperparameter optimization
Hmm.
and then I will report for precision and recall,
Hmm.
then I already have the part 4 also with me then.
Then you can just add the commentary. But
Okay,
part one is you haven't built the final tree. I mean, you just did the optimization, but you did not visualize the final tree in part one. So
okay,
part four talks about building that visualization of the tree. Remember, it says
yeah,
build a final DT with optimized parameters and submit that. So let me just clarify. Submit the tree. Submit that tree view basically. Submit the tree PDF along with your findings in HTML code. Hopefully that will clear some of the doubts.
yes, thank you.
Yeah. Mhm. Shall we wrap it up, folks? Any questions, comments from anyone before we close out for the day? Folks online, anything which is not clear?
No questions.
Okay. All right. I take it as a no. So it's a wrap, folks. Enjoy your day and rest of the weekend, and we'll connect again next time. Thank you.